Hi everyone, my name is Mark Moykins from Big Mountain Studio. Today I'm at the Bonneville Salt Flats in Utah, and I'm enjoying a beautiful day, and all this around me is actually salt. Keep watching, and I hope you enjoy my next video. Bye. Alright, in this video we'll be going over some common memory problems in iOS apps. We're specifically looking at memory problems that can be created with the Notification Center, Callbacks, and Delegates. If you're uncertain what these topics mean, then watch my series on Reusable Popups. I cover all three of these topics in separate videos and make them very easy to understand. This video will be using advanced methods of fixing memory problems. If you haven't seen Swift Memory Mastery Series, Part 1, 2, and 3 yet, then this content will be a little confusing because we're building off of what is taught in those previous videos. So if you haven't seen them, then please watch those first so you're not overwhelmed or confused by this video. Because we're basically taking everything we learned in those three videos and we're applying it to the Reusable Popup project. So watch those videos, they will guide you step by step through important and advanced topics to make you a master in Swift memory. In this video, we'll be looking at a project that was built as part of another series where I taught you how to create a reusable pop-up for your app that can be used from anywhere. We covered three different ways on passing data back from the pop-up to the view controller that opened it. We'll take what we learned from the previous memory videos and apply it to this project. If you're interested in watching that series on reusable pop-ups, then I included a link in the upper right hand corner of this video. Just look for the eye icon with a circle around it and then click on that. There'll also be a link in the video description too. This video will have three parts. We'll be exploring potential memory problems concerning the Notification Center, Callbacks, and Delegates. And again, if you're not familiar with any of these concepts or these topics, then I suggest you watch the series on Reusable Popups, because that series really goes into depth on what these three things are and how to implement them. Alright, let's jump into Xcode and start exploring potential memory problems with the Notification Center. Okay, we're in the Reusable Popups project, which was created from a series of videos on Reusable Popups. And we're going to cover memory problems with the Notification Center. So this is where we're going to start, but this isn't actually where I'm going to be checking for the memory problems. Instead, what I had to do is create another view controller, which is right here. So I'm going to click on this button right here, navigate away. And I'm going to navigate to another view controller, because what we want to test is to make sure that a view controller is completely unloaded from memory. And you can't test that with this project right here the way it's set up, because as you can see, it uses a tab bar controller. And what happens with the tab bar controller is when you click on these buttons down at the bottom on the different tabs, it loads the view controller, but it never unloads it, because that's just how it works. So it always keeps the view controllers in memory. So you can't really test it being unloaded from memory because, because iOS will never unload it from the memory. So what I have to do is navigate away from it and open up a brand new view controller, which is going to be this one right here. And as you can see, I made it a different color just so it really stands out, and you can see that we're actually in a different view controller. And when I dismiss this view controller by clicking this button right here, it should actually get unloaded from memory. And that's what I want to test with the Notification Center. I want to make sure when I use the Notification Center that I'm not doing anything that will keep this view controller in memory. Or the pop-ups. When I select date and the pop-up comes up, I don't want that to be stuck in memory as well. So how do we test and how do we know when a view controller actually gets unloaded from memory? Well, the easiest way I found how to do that is to add this dinit to my view controllers. Dinit gets called right before something is about to be removed from memory. So if this prints out right here, then I will know the Notification Center was deinitialized and it was removed from memory. Same with the pop-up. So if we go into the pop-up view controller, I also added that to the bottom right here. So I know when the pop-up gets removed from memory, and that's what I'm looking for. This will get printed out in the console down below. Right here. Okay, good. So what I'm going to do right now is I'm going to run the project, and let's make sure the pop-up is removed from memory, And this view controller with the notification center is also removed from memory. I'm just going to move this over here so we can see this console output here. And I'm going to navigate away because this view controller, now that it's being shown, cannot be removed from memory. Okay, so I select the date. Now we notice down here, the date pop-up view controller was deinitialized. So that means it was removed from memory. That's good. It's not being stuck in memory. And then when I dismiss this view controller, nothing showed up. So we do have a memory leak here. So we know that this view controller is not being unloaded from memory. So let's go into the code and take a look at what's happening. Okay, we're looking at the notification view controller. And let me just walk you through this. So we set up our observer, and this is going to hold a reference to our notification center observer that gets created. And then we have a closure here. And as you know from the memory videos, a closure is a reference type in itself. It's its own object that is stored in memory. So inside this closure, we use the parameter to get a reference to our date pop-up, and then we take that reference and we access the formatted date, and we assign it to a label that is on our notification view controller. So this self right here is a reference back to this view controller. So here we have a retain cycle, and it basically starts with this notification view controller, which has a reference to this observer, because it's right here. And this observer has a reference to this closure, and this closure has a reference back to the notification center. So let's take a look at this visually and see what it looks like. Okay, if we create a memory graph or a diagram, what the chain of dependencies looks like, we would come up with something like this. And as we can see, we have a retain cycle inside of our view controller. That is why it's not unloading. In order to break this cycle, we need to change at least one of these strong references to weak or unowned, or we need to somehow remove it from memory manually. We have a couple of options. Let's get back into the code and take a look at the first option. Okay, the first thing I'm going to do is I'm going to take this observer and I'm going to make this weak. And that is one way to break this chain of references, or this retain cycle, or this circular reference. Because the basic problem is the notification view controller has a reference to observer, and observer indirectly has a reference back to the notification view controller. So they both reference each other. So they both have a retain count of 1, or it's also called a reference count because it's automatic reference counting. One of those, the notification view controller and this observer through the closure, has a retain count or a reference count of 1. They can't be removed from memory. All right, so let's run this now and see if it works. Okay, we select the date, and that's fine. That gets removed, and then I click dismiss. All right, good. So we notice that gets removed as well. Okay, let's see visually how we fix this. So what we did is we made the reference to the observer weak, and that breaks the retain cycle. Let's look at our second option, where we can use a caption list. So I'm going to remove that weak. And from our Swift Memory Mastery series, we learned about capture lists and what those are. So we're going to add a capture list here. And as you know, it's just with 2 brackets, just like this. And it's for closures. So what I'm going to do is I can make this reference to self, I can make it weak or unowned. And if you remember from those videos, you use weak if there's a possibility that this self can be nil, or you use unowned if you know for certain that it's not going to be nil and it'll always be available. So I'm pretty certain that it's always going to be available. So I'm just going to make it unowned, like that. Now if I wanted to, I could give it a different name. I could say VC equals self. So it's kind of like declaring a variable, right? And then what I could do is I could replace this self with VC, and that'll work just fine, like that. But I can use the shorthand version too, and I can just make it self. Okay, great. So let's test that and make sure that works. Okay, we'll select a date first. Okay, it's run through our closure. It's run that code and it's populated this date. So now if I dismiss, it also gets deinitialized. Okay, good. So that's working. So here's what we did in this case. Down at the bottom, we made the reference to self an unowned reference. So that also breaks the retain cycle. Okay, good. Now that we handled the memory leak, there's one more potential problem that can happen, which is specific to notification centers. And I just want to make you aware of it so you don't make this mistake in the future. And it has to do with not removing the notification center's observer. So let me show you how that happens. Now in our project, we actually did take care of this by removing it on the view did disappear. But what I'm going to do is I'm going to comment this out. And a lot of times I've seen people, and I've done this myself too, where I've created an observer and I run some code, but I never actually removed it from memory. And here's the problem with it. So let's run the project and see what happens. Okay, when I click navigate away, it runs through my view did appear, right? And it added a notification observer. So when I click on a date, it receives a notification, populates my label. That's fine. I click dismiss. It removes the notification view controller from memory. So everything looks fine, right? But what happens is every time I come back in here, it's going through this view did appear and it's adding an observer to the notification center. So watch what happens when I set a breakpoint here. I select a date. It stops on my breakpoint. Let me run it. It stops again, and actually this time it throws an error. It says my unowned reference has already been deallocated. But why did it, and it runs again, and it says the same thing, unowned reference has already been deallocated. So why is it doing this? Why is it coming through and running this 3 times? It's because I'm not removing the observer. And the notification center, now notice we don't have to instantiate it. So basically the notification center.default is a singleton, which basically means there's always one object in memory. You don't have to instantiate it. You don't have to make many references to it. There's only one. So you can't remove a notification center from memory because it's always there. And I'm adding observers to it. So even though I'm leaving this view controller, the view controller gets deinitialized, but the notification center is always there. Let's see what's happening here. When you use the add observer function, it adds that information to the notification center's dispatch table. Dispatch basically means to send off a message or send a message off to someone. In this example, we see duplicate notification observers that we're adding to the dispatch table. So every time the view did appear happened, I'm adding a new entry to this dispatch table. The notification center exists statically in your app's memory or as a singleton. And like I said before, we didn't have to instantiate a notification center, right? You can just use it because it's a singleton and it's always in memory. It's much like the UIView.animate function, which is also a singleton. That means it isn't connected to a view controller. So if the view controller unloads, the notification center will still exist, along with all the observers that you added to the dispatch table. So remember, always remove your observers from the dispatch table with the remove observer function. So let's go back in here. We can remove this breakpoint, and we're going to remove this comment, so we remove the observer. Okay, that's it with memory problems with notification centers. Now let's move forward with callbacks. This next part should be fairly quick. Let's jump into the code and look at the potential problems we have with callbacks. Now if we look at the code, let's just walk through what's happening here. When I click on the button to show the pop-up, it grabs a reference to the pop-up right here with the pop-up variable. And I set this closure property right here to this closure right here. This is my callback. .save is the callback. And then I have a reference to self, this view controller. So this kind of looks like a memory leak as it is right now, right? Because you have the view controller and there exists a reference to a pop-up, and that pop-up has a reference to self. So it goes back around. But it's not quite a memory leak right now. Because what happens is this callback view controller doesn't actually have a reference to pop-up. Well, it does right here. This is its reference. But as soon as you go out of scope, as soon as it leaves this if block and it leaves this function, then popup gets removed from memory. That reference gets removed from memory. The popup is still in memory, but this reference gets removed. So when this reference is removed from memory, the reference count will go down by 1. Here's how we do create a memory leak, and that is if I create a variable, I called it popup, and it was a date popup view controller, then that will create a memory because this will hold on to a reference to the popup controller even after it goes out of the scope of this function. So this will always be in memory. So let's test it now and see if it gets removed from memory. Okay, I'm going to open up the pop-up, save the date. So we know this closure ran, this onSave closure ran, or this callback. And if I dismiss it, we notice that not only was the pop-up not unloaded, but the view controller, this callback view controller, also was not unloaded or deinitialized. So we have a problem. We have two things that are now in memory, and they both have a reference count of 1 because they're both referring to each other. So let's take a look at the memory graph so we can visually see what's happening here. So we have our callback view controller has a strong reference to the popup variable, and that's the one we just created. And that popup variable has a strong reference to the closure. The onSave is a closure. Closures are their own objects in memory. And then inside that onSave, we have a strong reference back to the callback view controller. So there's our retain cycle right there. Again, what we'll have to do is break this retain cycle by changing one of these strong references to weak or unowned. Or we can manually set one of these objects to nil to reduce the reference count. And I'll show you how we're going to do that in Xcode. Okay, the most obvious thing that I'm going to do right now is just make the pop-up a weak reference. So let's test that and make sure it works. Select a date. Now we should see this pop-up deinitialize. And it does. Okay, good. And then I'm going to dismiss this view controller. And we see that also gets deinitialized or deallocated. Good, so that works. Now I'm going to change that back. And can you guys think of the second thing that we can also do to break this retain cycle? Yeah, we're going to use a capture list here. And I'm going to use unowned self. And remember, we can also use weak as well. That'll work as well. And just to show you how that works is, if I do change this to weak, there's something else I'm going to have to change in my code, because this self now is optional, so it can be nil. So I'll just have to add a question mark. And that's the difference between weak and unowned is, if it's weak, it can be nil. If it's unowned, then it means I definitely always have a value there available when this code runs. All right, good. So let's test that, make sure that works. Select the date. That should get deallocated. Oh, yeah, this one's a little bit different. So notice the pop-up didn't get deallocated. It's still in memory right now. But if I click dismiss, then they both get deallocated at the same time. And that's because the view controller, if we look at the code, the view controller here has a strong reference to the pop-up. So it's going to hold on to that reference as long as this is in memory. It's going to keep this in memory. I don't know if you guys remember that about strong references. It basically means a variable will always be in memory as long as the parent is in memory. So when the parent, or this view controller, gets removed, all of its children get removed as well. So the third solution that you can do is you can also set this variable to nil. And when I set it to nil, it's going to reduce the reference count by 1. So by manually reducing that reference count by 1, it breaks that reference cycle or that retain cycle. So let's test that. Okay, the pop-up was deinitialized. And then the view controller was deinitialized or deallocated. All right, awesome. So everything is working perfectly. Those are 3 options that you have right there. So let's review our solutions and see how they fixed our retain cycle. Our first solution was simply to make the pop-up variable weak. Our second solution was to use a capture list and change the strength of self to unowned, and we could have used weak too. And finally, our third solution was to set the pop-up to nil after we were done using it. In this way, we manually lowered the reference count by 1 so it could be removed from memory and therefore breaking the retain cycle. And I just want to mention here too that this is what is actually happening when we don't have a class level variable as pop-up. As soon as it goes out of the scope, it leaves the function and the reference count goes down by 1. If you can think of other solutions, please feel free to offer them up in the comments below. Okay, and on to our last part, we want to be talking about potential memory problems with delegates. So let's take a look at delegates and what possible problems we might have with them. Okay, so here's the delegate view controller. And as you can see, I have a D in it coded here so we can tell when it gets removed from memory. And this one works a little bit differently because I'm not using a segue. Instead, I'm using a button. And when I click the button, it's going to find the storyboard. And then from the storyboard, it's going to find the view controller. And then it's going to set the delegate to self. And as you can see down here, I conform to this protocol pop-up delegate. I handle this pop-up value selected. So basically the pop-up is going to call this function and I'm going to supply it the code. All right, so let's test this now just to make sure where we're at. Is it working? Is it not working? Okay, click on save time. That looks like it's working. It's getting removed from memory. And I dismiss this view controller. And that looks like it's working too. Okay, good. So right now it's in a working state. So let's explore the possible problems that we can have. Okay, now as you saw before, we can create a memory leak if I create a variable, a local variable here, for the pop-up. All right, and since I made it optional, I got to include some question marks here. And I have to ensure that it actually exists when I pass it into this present function. This is what actually shows the pop-up. Okay, let's run it and see if that causes any problems. And as I think you can imagine by now, that will create a retain cycle. As you can see, the pop-up was not removed from memory. And the view controller was also not removed from memory. Okay, so by this time, I think you guys know why we have a retain cycle. Let's just go over it again so you guys have a clear understanding on what's happening here. Okay, here's what our retain cycle looks like when we're using the delegate. And as you can see by now, with these graphs that I draw out, I always start with the view controller because this is what I believe is the parent of the two classes in the retain cycle. So we have the delegate view controller and the date pop-up view controller that are holding on to each other. And if you remember from the Swift memory mastery video, there are 2 steps recommended for fixing the retain cycle. The first one is identify who the child is. And in this case, it's our pop-up. Our pop-up view controller is our child. And I'm making the view controller the parent. Then the second step is to make the child have a weak reference or unowned reference back to the parent. So in this graph, where's the reference back to the parent? It's the delegate property. The delegate property holds a reference to the delegate view controller. And we can confirm this by going back in the Xcode and looking at the memory address. Let's take a look real quick so you know what I mean. Okay, I'm going to go into the date pop-up view controller. And we can stop this for now. And I'll just set a breakpoint right here. And this is in the view did load. So when the pop-up shows up, we're going to take a look at the memory of this delegate right here. Actually, there's one more breakpoint I want to set. And yeah, let's put it right in this, right when we click the button. So navigate away, select time, you'll hit the breakpoint. And the self for this delegate view controller, look at this memory address right here. So it ends with A5900. All right. And if we take a look at the delegate right here, so the delegate has a reference to that view controller, and you can see it right here, A5900. So this delegate property and our delegate view controller have the same memory address. And that's why this pop-up has a reference back to our view controller is through this delegate property. So if we want to make the reference back to the parent weak, then what we want to do is make the delegate property in our pop-up weak. So let's do that now and see how this works. I'm just going to remove these breakpoints. Okay, in the date pop-up view controller, what we want to do is we want to make this delegate weak. But let's look what happens here. Okay, we get an error message. Weak may only be applied to class and class-bound protocol types. Not the pop-up delegate. Okay, so what does this mean? Why can't I make this delegate weak? This is a pretty common pattern, and you pretty much see this used everywhere where there's delegates. You always make the delegate property weak. So why is it giving me an error? It's saying that it can only be applied to class and class-bound protocol types. Well, in order to understand that error message, we need to know more about protocols. And Apple says, the protocol can be adopted by a class, structure, or enumeration to provide an actual implementation of those requirements. The important part here to understand is that protocols can be applied to value types as well as reference types. And currently, the way our protocol is declared, Swift thinks our protocol is being adopted by a value type, and you can't apply weak to value types. So we need to bind or restrict our protocol to a reference type so Swift knows it's a reference type. So how do we do that? Here's how we are currently declaring our protocol. So what we need to do is make our protocol bound to just classes, or restrict this protocol to just classes. Apple tells us exactly how to do that in their Swift documentation. Apple says you can limit protocol adoption to class types and not structures or enumerations, value types, by adding the AnyObject protocol to a protocol's inheritance list. Okay, so that's exactly what we want. We want to limit adoption of our protocol to just class types, so Swift knows it's a reference type. Now that Swift knows it's a reference type, we can then make it weak. So our protocol will inherit from any object like this. So let's go back into Xcode and make that change to our project. And since I'm here, what I'm going to do is hold down Command, and I'm going to right-click on Pop-up Delegate. And I want to restrict this protocol to only be used by classes to make them reference types. And I'm going to use AnyObject. Okay, so let's navigate back to our pop-up. I'm just going to hold down Command, Control, and then left arrow to navigate back. And let's build this and see if that error message goes away. Okay, we rebuilt it, and the error goes away. So I got to explain what just happened here. The first time I built it, I still get that error message. So I think that was an error in Xcode, because it actually wasn't a problem. It wasn't until I actually ran the project that the error message completely went away. So that did fix it. By adding the AnyObject to our protocol, we're now able to make it weak. So let's run it and make sure that everything is unloading from memory correctly. Yeah, look at that. See, the error message still comes back up, which is wrong. I don't know why Xcode is doing that. Maybe it's a problem with Xcode 9.2. That's the version I'm using. Okay, so let's go to Delegate, and we're going to navigate away. We're going to select a time. And notice the pop-up doesn't get removed at this point. But when I dismiss the view controller, they both get removed from memory. So I don't know why this error is still showing up, even though it's not an error. Maybe what I have to do is clean the project. I'm not sure. Nah, it still keeps coming up. Okay, this might be a bug in Xcode, but as you saw, it does still work. Okay, so let's review what we just did. Here's what our graph looks like now. We broke the retain cycle by making our delegate have a weak reference back to the class that is assigned to it, the parent. And like I said before, this is a pretty standard practice, and it's a good practice to keep in mind and follow when working with delegates. Now, of course, you do have other options. Making the delegate weak is the best one in this case. You could have also assigned nil to either the delegate or the pop-up property once you are done using them. Or you can also make the pop-up weak like we did previously. So let's explore some of those options. Okay, we're going to go back to our delegate view controller. And actually what I'm going to do is let's go back to the delegate and let's remove the weak. And then we'll go back to our delegate view controller and I'm going to make the pop-up weak. And let's run that. We'll test it, make sure that works. And by doing these exercises, you should start getting the idea now of how this is working, how we have a retain cycle and how we can break any one of those strong references to fix our retain cycle. Okay, in this case, since we made the pop-up weak, when I close it, it automatically gets deinitialized right away. And if I dismiss the view controller, we notice that also gets deinitialized or removed from memory. That's fine. We can make this pop-up variable weak like we did the previous two times. I talked about a couple other options of making some variables nil after we're done using them. And we do that right down here. So remember, this whole class gets passed in to the pop-up right here. We're assigning self to delegate. So we're passing in the whole delegate view controller into the pop-up through the delegate property. So when you click on the select time in the pop-up, it's going to call this function right here and run this code. So in this code, what I can do is something like this. I could say popup.delegate equals nil. So then when this code gets run, it's going to set this delegate to nil, so it no longer has a reference to this delegate view controller, which will lower the retain count by 1. So remember, when I click on save time, it's going to run this code, it's going to make the delegate nil. And then if I dismiss, they both get deinitialized or removed from memory. Okay, so that's one option. I'll just comment that out for now. Now, another option too is we can actually just set our pop-up to nil. Like that. And what that's doing is it's actually taking this property right here and it's setting it to nil. So let's test that and see if that works. Okay, so when I clicked on that button, it set this pop-up to nil and it deinitialized it and it removed it from memory, as we can see down here. And if I dismiss this, it also removes the view controller from memory. So there you go. You have many different options for breaking this retain cycle at different points. We set the delegate to nil, we set the pop-up to nil, or we can use weak references by setting the delegate as a weak reference or setting the pop-up variable as a weak reference. So you have some options in breaking this retain cycle. All right, great guys. We explored a number of different ways to fix our memory problems, our retain cycles, and we did that by using weak or unowned. We also use capture lists, so we can change variables coming into a closure to weak or unowned. And we could also fix some retain cycles by setting variables to nil, which manually would lower their reference count by 1 so they could be removed from memory. And then lastly, we fixed our delegate memory problem by making it weak, but before we could make the delegate weak, we had to change the protocol and inherit from any object. So it restricted that protocol to just classes. So at that point, Swift knows that our delegate was a class or a reference type. And that was the only way we could make it weak, was to make it a reference type, because you can't make value types weak or unowned. All right, guys, thanks for watching. Consider subscribing if you want to see more videos like this. If you want to help out the channel, feel free to supply a translation for the title and the description in your native language so other people in your country can also find these videos. And finally, hit the like button if you like this video. All right, thanks, guys.